what happens if you don't have holistic quality? What's the cost? That's usually going to be cost of fragmentation. We know that 83% of executives acknowledge the fact that there's a presence of data silos within their organization. And those data silos can be geographic by continent or by nation. They can be by division and function. They can be by individual facility or by individual line. And sometimes it's even down to the individual machine. Data silos means you can't see all this stuff in one place. We also know that 70% of manufacturers admit that they still rely on manual data entry somewhere in their process. And we know that only 16% of manufacturing leaders globally report that they have real-time WIP monitoring across the entire manufacturing process. So if you fall into one of those big buckets, recognize that you're pretty much aligned with the rest of the world. It's a hard thing to figure out. And so one of the things that Minitab has really invested in doing over the last 5+ years is trying to bring all of that stuff together, create an entire picture of the holistic manufacturing process from end to end so that we can take the different fragmented pieces and put them together to create a clear image and a clear visual so that quality becomes truly comprehensive from end to end across the entire organization. And that's what holistic quality really is. We define it as an approach to quality that looks at the entire system that creates value. It treats quality as a company-wide responsibility that spans people, processes, technology, and culture, with the goal of consistently delivering outcomes that customers trust and organizations can sustain, creating visibility, traceability, and confidence in every decision. And that last piece, the confidence in every decision, is something that I'm going to mention a few times throughout this because we know that the output of pretty much every engineering project is a decision point. Do we do A or do we do B? Is this good or is it bad? Making that decision with confidence is really what separates a lot of successful projects from unsuccessful ones. So what are the pillars of holistic quality? Holistic quality is built on these 3 pillars: visibility, accountability, and predictability. Visibility means seeing both the impact and the system that creates it. Quality is not just an engineering metric, it's a financial one as well, because every defect prevented, every process stabilized, and every decision validated improves cost, speed, and customer trust. But true visibility also means seeing inside the process, into the data, the measurements, and the improvement work happening every single day. Real-time, automated insights into performance, root causes, and project progress make quality transparent and actionable across the entire organization. Accountability means that quality is shared. It's not owned by a single function of just quality engineering, but by every team across the entire product lifecycle, from R&D to NPI to manufacturing to quality itself. And when data and decisions are connected, ownership becomes collective and quality becomes cultural. And then there's predictability, which uses analytics to turn that visibility and accountability into foresight. By understanding how inputs shape outcomes, we can model what's likely to happen next and prevent problems before they occur, answering the what if question before it becomes a, oh no, what now? So together, these pillars transform quality from a set of metrics into a living system that drives trust, performance, and sustainable success. Quality is everybody's responsibility, and it starts at the very beginning with R&D, which is where the foundation of quality is built. Their responsibility is to design products that are not only robust, but also manufacturable. And they can be manufactured consistently well, setting the standard for everything downstream. Because there's no amount of added testing or inspection or quality measures that can make up for a fragile design or something that's difficult to manufacture. And one example of this is when I was a manufacturing process engineer in the automotive industry, we made thermal fluid system products for engines, for engine components. You go pop the hood on your car, there's a very strong likelihood that one of the components that my company made at the time is in one of those engines. And we sold to all the OEMs. And the irony is that there was one particular OEM that asked for the most stringent quality standards, the most stringent testing, and the most stringent inspections. My understanding was that was pretty consistent across their vendors. And when you look at the actual on-road quality metrics of that organization's vehicles, they were among the worst. So just because you have additional quality standards and inspection does not make up for a fragile design. So it's something that we're very aware of. We aim to deliver products and systems that enable R&D engineers to deliver the best possible designs every single time. After R&D, there's a new product introduction, which bridges that design into the reality. They validate processes, balance production flows, and make sure that what worked in the lab works on the line as well, turning something that can make one into something that can make 10, 100, 1,000, maybe even 100,000 units a year. Process engineering, they take that and they harden it, embedding quality directly into how things are made through automation, error proofing or poka-yoking, and continuous monitoring, so that when it finally gets to quality engineering, they get to focus on closing the loop, turning that data into insight, verifying results, finding root causes alongside process engineering teams, and feeding lessons back into design. So what you end up with is a closed loop quality system where feedback goes to R&D and MPI for lessons learned every single iteration, so that every time you make a new design or a new process, it's better and better and better over time, which feeds directly into the financial success of the company, because you're going to get enhanced customer loyalty, more sales, those profit margins can possibly expand, and the company is set up for success. Quality issues are directly correlated to a manufacturing business's financial performance. We know that the cost of poor quality manufacturing can equal 15 to 20% of a company's total sales revenue. And we consistently see this anytime there's an automotive recall. If a company has to recall a car, let's say model year 2017 through 2021 of something, that company needs to invest in the redesign of that default product or that defective product, the production of all the replacement products, the installation of those products. So it's something that absolutely shows up. We also know that process downtime costs manufacturers an average of $250,000 per hour. And so I remember when I was a manufacturing engineer, anytime that production line went down, it was all hands on deck to bring it back up and running. It did not matter what else we were working on. We had to get that production line up and running, because you can't sell something that you haven't built yet, and you can't build something that the process isn't up yet. We also know that manual data entry leads to delays, inconsistencies, and lost visibility, costing manufacturers an estimated $1.5 million per year in rework. And we know that 73% of manufacturers say they lack visibility into potential quality issues until after the issue actually occurs. So building a connected, data-driven quality loop isn't really optional anymore. It's the only way to operate with confidence. So imagine a world where you could do all of the following with a single set of tools. You can collect operations and quality data from the plant floor and display that information directly onto customizable dashboards that are specific to your process, specific to your product, and specific to your data, so that you have confidence in exactly what you're reading and you know exactly what you need to do whenever information pops up on that screen. So that when something actually occurs, for instance, something is trending out of control, you can see and get notified of it right away, create and execute various projects to try to address the situation, and perform experimentation, in-depth investigations in a structured way that enables you to do complex data analysis, analyze outputs, to ultimately make a decision with confidence about what to do next. What's the best way to prepare for a 10% capacity increase next year? Is this really a defect, or is it conforming? Do we scrap this part in assembly, or can it actually be reworked? Did we test enough fringe factors to be confident in this design? And this product passes testing now, but it's been through a lot. And will it last for 15 years in the field? We spent the last 50 years helping organizations master quality, and today the challenges are greater than ever. Costs are higher, there's tighter margins, stricter regulations, constant pressure to deliver more with less, and enhanced competition across the board. So that's why we've reimagined what quality can be. And we've invested heavily in the capabilities to build a connected ecosystem that brings together your people, your process, and your data, giving you the visibility, traceability, and confidence to make the right decisions faster. But what does it actually look like in practice? We're going to start with R&D, designing and developing the best products. Imagine a world where you're an engineer on an R&D team and you want to build a complete product development project from end to end, 0 to 1, design idea and concept to design delivery. And imagine having that unified toolkit that can handle your roadmap, your brainstorming for creativity, your design and execution of all of your experiments, the collection of all of the data from those experiments, performance of the analytics, and then generating insights from those analytics and the outputs of those analytics to make effective decisions that are iterative and traceable. So that, because product development is a linear system, it's a very long path, it's a very long process. So imagine you could go from end to end with one connected ecosystem, doing one experiment after the next to get to the final output. So imagine you get that final product delivery. and you hand it over to the new process introduction team. NPI teams have a pretty tough job. They have to take that design concept that the R&D team delivered and create the process that the process engineering team is going to use to build the product. They need to do a lot of experimentation, a lot of brainstorming, a lot of data analytics, but they also need to define the layout. They need to figure out, are we going to do this in 5 steps, 10 steps, or 20 steps? And within each one of those steps, how many machines do we need? How many personnel do we need? And what's the cycle time going to look like across every single step? What are the defect rates going to look like and the scrap rates going to look like? What's the capital expenditure we're going to invest in this system? What's the optimal flow? There's probably 20, 30 different ways that we could set this up. So imagine being able to visualize it ahead of time. Imagine being able to put out all the potential designs of the workflow and test what each one would look like so that you can find the optimal process that works for your situation and have confidence based on that data output from those simulations that you are executing the right project before you even spend a dime, before you do any level of actual work. That's confidence in motion. Now imagine you implement that manufacturing process. You go through the process of buying all the equipment, training all the people, you set it up, and now the process engineering team is building it and monitoring products from end to end. And imagine you're inspecting different critical dimensions across the board, across the plant, at different stages within that process. Imagine you're monitoring one specific critical dimension, and it's on the trend chart. And all of a sudden, you watch that dimension start to drift out of control. Now, it's not quite out of spec yet, but you can tell that it's probably going to be at some point. And you can't let it get there, because if it does go out of spec and it's a pattern and it's trending, that means you're probably going to get more and more failures. And if you start out putting too many failures, the likelihood of having to shut the line down to try to correct the issue is pretty high. And we already know it can cost up to $250,000 an hour to have that line down. So you want to address that problem in the moment. Imagine having the ability to see it happening live so you can address the problem before it actually ever becomes a problem. And you never have to shut the line down once, you never get a single failure. That is true holistic quality at the operational level. Now imagine you do address that and you go ahead and you trigger a project and you open it up and you have a structured, methodical process that you can be confident in to get to root cause with your team, knowing that you can follow different lines of investigation using standard tools like process maps and fishbones and 5 whys. My personal favorite is the 5 why, to get to root cause, knowing that every string of investigation that you go down is going to be recorded and stored so that there's going to be lessons learned throughout the entire process. And when you do finally get to root cause, you can showcase all the work that your team did to get there, knowing that you turned over a lot of different stones before you really got to the root cause of what's going on. And then you can save that as a record to be able to show, look at our process, look at what we did, look at what we found. Now imagine there's some data analysis that you need to perform and some experiments you need to run to actually prove that that was root cause, right? Imagine being able to go into the same portal, trigger an experiment, design that experiment, execute that experiment, collect the data, analyze the data, get an output, and then have natural language-based AI give you a complete summary of what that analytic is really saying so that you understand the true nature of the story that that data is trying to tell you. So you walk out with absolutely 0 question marks and you can make a confident decision of, yes, this is absolutely root cause. Here's why I know it. Let's move forward and make this decision in this way for this reason. That's holistic quality. Now imagine you go through that process, and it happens not infrequently because that's just the nature of manufacturing. Things go wrong, right? But imagine the iterative nature and the cyclical nature of this whole holistic quality system is proving to be pretty successful. And leadership comes to you and says, hey, the market is really loving the products that we're making. They work, they're robust, they meet their needs, they're reliable, and they want more of it. And we're expecting to experience a demand increase of about 10%. So we need to increase our capacity by 10% in order to meet that demand, and we have about 6 months to do it. How are we going to get there? Are we going to buy more equipment? Are we going to hire more people and train more people and build out more stations? Or is there 10% of inefficiency that we can pull out of the existing process and we can do it all in the exact same system without having to buy more equipment and having to train more people and having to invest in that capability? Or is it somewhere in the middle? Imagine being able to use the same simulation system that you used previously to test every what-if scenario to identify the optimal path forward that balances cost, time, quality, and output all at once, and knowing exactly which path you want to take before you take a single step or spend a single dollar. That's holistic quality at a strategic level, using simulation and analytics to build confidence in every change before it reaches the floor. Everything I just mentioned, everything I just talked about they can be individual circumstances. They can be individual situations. They can be piecemeal, absolutely. But there's also going to be circumstances where there's a single project that requires that comprehensive cyclical nature. Imagine a world where you're a process engineer and you detect a quality problem before it's a failure. Identify and verify the root cause of it. Launch and manage an improvement project to develop a corrective action. Simulate and optimize potential workflows before you actually implement the solution. Validate process capability and confidently release to production and have a record of every step of the way. That's holistic quality in action. And that's what we spent so much time and money investing in over the last handful of years, is preparing that solution for you. Because quality is not just a department, it's a discipline. Idea generation and management, project planning and management, problem-solving methods and simulation, predictive analytics and machine learning, statistical analysis and business intelligence, data access, automation, process monitoring, are all tools in an engineer's tool chest that enable them to execute projects at a very high level and having confidence in the output every single time. And that's what the Minitab Solution Center is all about. So this is a unified platform combining analytics, visual tools, and data integration into one workspace. It has the statistical product of Minitab statistical software. It has the problem-solving workflows of Minitab workspace and brainstorming, the dashboards of visualizations that you can have up there. And then it has Minitab AI, natural language processing of data summaries from your output so that you can make clear, concise decisions about what that data output is really saying. And then there's Simulate, a discrete event simulation software that enables you to drag and drop different stations, different equipment, different personnel, different workflows, and simulate every option, every potential situation that you might encounter so that you can visualize exactly what a potential workflow might look like and test every what-if scenario. And there's ProLink, our comprehensive real-time data collection and SBC software that enables you to take measurements from any CMM, any gauge, any scale. I believe the number is 200 or 300 different connections that we can make across a factory, and have the data from those inspections be automatically uploaded to different various spreadsheets and then charted live so you can see what's going on as it's happening. And then there's Minitab AI, our standard statistical software that we've been developing for the past 50 years, now with AI to analyze outputs and provide summaries of exactly what that output is saying. So there's no guesswork involved. You walk away with a clear understanding of what that data is telling you to do. Companies with end-to-end visibility report a 33% faster response time to quality events. And that's what confidence ultimately looks like in action, a system that closes the loop between people, processes, and data.